By the way, I didn't forget about that. This time I made a note here about the quiz question. It's apparently, how do DC devices in your house work if the power coming in is AC? The answer is they use full bridge rectifiers with capacitors. How does it work? Well, basically, AC current is like this. So, full bridge rectifiers turn this into this, like a bouncing ball. And then the capacitors turn this into this. And with that type of current, most of the devices in your house run just fine. So, with that out of the way, let's start talking about batteries. Wait, we first need to talk about how batteries were invented. They have a very interesting story behind it. So let's talk about that first. So, a long time ago, in Italy, there were two scientists. First one was Alessandro Volta. He was the guy I mentioned in the quiz question a few episodes ago. I said he made a really important invention, right? Well, that invention was the battery. The second scientist was Luigi Galvani. Now, Luigi, while working on his experiments, noticed something very strange. When he rubbed a frog leg, yes, a frog leg, with a piece of metal, the frog leg seemed to twitch. Here's the thing though, it only seemed to work with metal. He tried rubbing it with glass and it didn't work. So these observations were very interesting. So he sent it to his scientist friend Volta. Now, Luigi thought, if the frog leg is moving, then there must be some electricity in the frog leg causing it to move. But Volta sent the letter back with another possible reason. I think the reason is because the amount of metal you used was generating electricity that caused the frog leg to move. I think the reason glass didn't work is because glass can't generate electricity like that. But then Luigi sent back another letter. Well, I think I am right and you are wrong, but that doesn't matter. I want to share the results of my other experiment. If I took a very, very long copper rod and put a bunch of frog legs on them, the frog legs started dancing. Seriously. So, this is a very strange observation, and I think it confirms my theory. But then Volta said, well, I have an observation that totally confirms my theory. You see, if you take 2 tubs of salt water, regular water won't work, and then put copper in one and zinc in another, and link them by a wire, electricity goes through the wire. So this shows that the metal is generating the electricity. So that's the reason the frog legs are twitching. And Luigi got very angry and sent another letter saying why he was right. But then Volta answered with one final experiment that settled it all. And that was the creation of the voltaic pile. So if we take some pieces of copper and zinc and stack them on top of each other, separated by layers of solid cardboard, and link the top and bottom of the stack with a wire, electricity flows. The copper and zinc must be generating electricity, proving my theory right. This was the invention of the battery. Now, what happened to the two after that? Well, it was around this time that Napoleon invaded basically all of Europe. And when he came around to Italy, well, Galvani was a critic of the emperor. So he fell out of favor. But Volta made a smart choice to support him. and he became a close friend of the emperor himself. And we got the metric unit, the volt, named after him. So, always make sure if your idea happens to be correct, it might set up a chain of events that leads to people naming a unit of voltage after you and having a big invention which is at the core of the 21st century. So, that was a long time ago. Now, instead of using soggy cardboard, which is wet, we use more advanced materials. The soggy cardboard is, well, soggy and wet. So, the battery that Volta invented is called a wet cell. But in modern times, we used dry cells. So, how do these dry cells work actually? Well, let's explore that in our next segment. So, remember how most of the time we call the positive end of things the anode and the negative end the cathode? Well, in batteries, it's the exact opposite. The negative end's the anode, the positive end's the cathode, and I don't understand why. Anyway, instead of using the alkaline battery I showed you at the start, we will use modern, rechargeable lithium-ion batteries, also known as power banks, for our example. So, this is our battery. It's a very nice battery, as you can see here. Now, it has two ends. Firstly, we have the negative anode, and this end is made out of graphite, which is just the thing in your pencil. The black lead in your pencil, that's graphite. It's made out of carbon. So it's made out of graphite, which is just carbon, and lithium. That's why it's called lithium-ion. So we have graphite and lithium. Now the graphite and lithium aren't just spread around willy-nilly. They're layered in a special way called intercalation. Now, on the other side of the battery, we have cobalt oxide, which is represented as cobalt O for oxide. So, we have graphite and lithium here and cobalt oxide here. This end is the positive cathode. And in between them, there's the electrolyte. Now, the electrolyte has a separator in it. Okay. So, what happens when the battery is running? Well, lithium is a very unstable element. You know, there's some special elements called noble gases, and they are very popular. Every element wants to be like them. And lithium is just one step away from being a noble gas. It just needs to remove a single electron and it will be a popular noble gas. So, lithium really wants to get rid of that electron. Now, we made a whole video about this, which you can watch here, but this is all you need to know. Now, lithium, when you're discharging the battery, which means the battery is powering something, the lithium loses one of its electrons. So, now the lithium is positive and you have an extra electron here. Now, this is a lithium positive ion, right? So the lithium ion goes to the other side. Now meanwhile, the electron here, the electron goes through the wire that connects the two. So you have the electron which is traveling here, and eventually at the positive cathode, the lithium ion which is positive, and the electron, which is negative, will meet up. And they'll mix with the cobalt oxide, which we have here, and they will form lithium cobalt oxide. Now the lithium has a positive charge, the electron has a negative charge, so they cancel out and we get plain lithium. And this electron, which passes through the wire, we can get that electron to do useful work, like powering a bulb. So there are two reactions, one that happens while charging and one that happens when powering or discharging. Here's the thing though, these two reactions are the exact same, one is just in reverse. So we could just make a single reversible reaction. So this is what happens. You start, so at the anode, remember, you have graphite and the lithium. Now, they are intercalated in a special way. They're layered, called lithiated graphite. So that is how we start. At the anode, we have some lithiated graphite, and then what happens is that goes into graphite plus a lithium ion plus an extra electron, and this electron powers the whole system. Now, what happens over at the cathode? Well, you have the lithium ion that's come over through the electrolyte, and you have the electron which come over through the wire, busy day of powering something, and you have the cobalt oxide which is already there, and they react to form lithium cobalt oxide. Now, what we do is to get the full battery reaction, we add these two reactions together. Now, the lithium ion and the electron are on the negative side on the anode, they're on the positive side at the cathode. So when we are adding them together, they actually cancel each other out. So, what we could say is that the lithiated graphite plus that cobalt oxide transforms into normal graphite plus lithium cobalt oxide. Now, this is just a discharging reaction, but it could happen reverse, and that's called charging a battery. So, instead of using this arrow symbol, the arrow symbol states it can only happen one way, but it can happen in reverse too. So, instead, we use this symbol, which indicates that the reaction can happen either way. So, this is the full equation of the battery. Lithiated graphite and cobalt oxide transforms into graphite and lithium cobalt oxide. The lithium splits into lithium ions and electrons, which take different paths before joining together and becoming lithium again at the end. So, now you know how batteries work. Na-na! So let's quickly recap what we learned. We learned about how batteries were invented by froglegs and feuding scientists. Hey, that kind of rhymes, right? But anyway, we then learned how the modern lithium-ion batteries of the day work. So, that's it then, right? Well, no, we're missing one slight thing. Ah yes, the something you have to research yourself. So, here's a quiz question. Who is the oldest person to ever win a Nobel Prize? Clue: he got it by doing work on batteries. Send me the answer and I'll see you next time on the Funtastic Academy. Bye bye! Dun 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 dun.